Jai Hind all. Myself Amita Asthana from AKGEC Ghaziabad. In this video lecture, we will study about the subject signal system according to the AKTU syllabus, that is KEC 403. And in this particular video lecture, we will be studying about the calculation of discrete time Fourier transform, as well as few concepts about that. So here, coming to the definition of Dtft, this discrete time Fourier transform, as we have the Dtft in short, and this is defined only for the discrete sequence, For continuous, we calculate the CTFT, continuous time Fourier transform. For discrete sequence, we calculate the discrete time Fourier transform. So here the Dtft to be represented as xeg omega, okay, and xeg omega can be represented in terms of its real part and imaginary part as xre e raised to the power j omega plus jx imaginary part of e raised to the power j omega, where xre e j omega and x imaginary e j omega are respectively the real and imaginary parts. Okay. Now the magnitude will be the mod of x of e j omega, and angle would be argument of x e j omega, that will be imaginary tan inverse imaginary part of x e j omega upon real part of x e j omega. So here we can define the Dtft as follows. Now this is the x e j omega is the magnitude function, as already I have mentioned, and theta omega is called as phase function, right? The Dtft is the Fourier spectrum. As I can tell you, whenever we calculate x e j omega, okay, by applying this particular formula, whenever we calculate, this is a continuous spectrum, okay. So when it is a continuous spectrum and we are converting a discrete sequence into a continuous form, then how to get the discrete part back from this particular spectrum is, for that we calculate the discrete Fourier transform, that is well known as DFT. So Dtft and DFT are related with each other, like DFT is the sampling of Dtft, because whenever it comes to a aperiodic sequence, the Fourier transform of this aperiodic sequence would be continuous in frequency domain, and when it becomes continuous in frequency domain, we can sample this particular by calculating DFT. So converting to Fourier transform and then performing the sampling, these two processes can combined for the DFT term, okay. So here it is written, the Dtft is called the Fourier spectrum for discrete sequence always, and the x e j omega and theta omega are known as the magnitude and phase spectra, right. So for the real sequence, xn, x e j omega and x r e j omega are even, right. This point to be noted. For a real sequence, xn, x e j omega and x r e raised to the power j omega are even functions of omega, whereas theta omega and x imaginary e j omega are odd functions of omega. So for real sequence, that means when the sequence is totally real, there is no complex term or complex part in any term of the sequence, then we can say for a real sequence, xn, x e j omega and are even functions of omega, whereas theta omega or imaginary are odd functions of omega. So we can note down the x e j omega is nothing but mod of x e j omega e raised to the power theta j plus 2 pi k, mod of x e j omega e raised to the power j theta omega. So phase function of theta omega cannot be uniquely specified for any Dtft. See, whenever we are calculating the Dtft, we are getting the sequence in its frequency domain. Now let us calculate sequence Dtft. Let the sequence is given as xn e raised to the alpha raised to the power n un, where un is the unit step function. And it is in discrete sequence, right? So how to calculate this? As we have the formula that Dtft is nothing but x e j omega. I rewrite is for any discrete sequence. This is from minus infinity to plus infinity as it is written here. Now whatever the sequence xn e raised to the power minus j omega n. So this xn is this term and e raised to the power minus j omega n is written like this. So here we can simply see that the sequence into e raised to the power minus j omega n for the summation minus infinity to plus infinity can give me the Dtft value. So here this un is only for 0 to plus infinity. This is un. So my limit will change to 0 and this will be infinity, because this un is specified only for the positive values, and for all it is equal to 1 because it is unit step. And now what this will be, if I just expand it, then it will be 1 plus, okay, that alpha e raised to the power minus j omega plus alpha square or alpha e raised to the power minus j omega square plus and so on up to infinity. Now this is the summation of an infinite term. Here it is given that this mod of alpha is less than 1. So whenever we have the sum of infinite series, this to be less than 1, see here this to be less than 1, and we can represent it by s is equal to 1 upon 1 minus c. So we can put the value, and here this becomes s x of e raised to the power j omega, and this is my Dtft for this sequence, right? So in this way we can calculate the discrete time Fourier transform for the given sequence. Now discrete time Fourier transform equations. So this is for, as already I have discussed, that this x e j omega, that is Dtft for discrete, obviously this is for discrete sequence, this is minus infinity to plus infinity, and this is the xn e raised to the power minus j omega, and hence it gives a Dtft, and this is known as analysis equation. This is known as analysis equation. And similarly for xn 1 upon 2 pi for the whole period x e j omega, here this term will be positive. See, it's a point to be noted that here we are having the positive term, and this will give me the inverse Dtft, that this will give the xn back. So getting the xn sequence back from the calculated Fourier transform, or as we say Dtft. So this particular equation is known as synthesis equation. Now this synthesis equation, finite integration interval must be there and x must be finite. For analysis equation, okay, for analysis equation, that means for calculation of Dtft, as we have already studied about the Dirichlet conditions and the absolutely summation properties, also the finite number of discontinuities, all these criteria must be followed followed for the Dtft, as we have seen in CTFT. The continuous time Fourier transform and the discrete time Fourier transform actually needs the same criteria to be followed whenever we are calculating or converting to the corresponding Fourier transform. So here, this is the condition for the finite energy. The signal must have a finite energy in the domain minus infinity to plus infinity, that's one. And this signal must be absolutely summable, and these conditions are same as we have done for CTFT. So Dtft also needs the same conditions, and the CTFT also needs the same conditions. So both are in need of these conditions so that the Fourier transform conversion can be possible for continuous as well as the discrete time signals. Now coming to the one more example, that is xn is equal to del n, that is impulse equation. Let us calculate the Dtft for this particular sequence. So we have this particular formula, and as we know, this is only defined for 0 and this value is 1, because here we have considered the unit impulse function, so this will give you the 1. So, and hence we can conclude that the unit sample sequence xn is equal to del n, and x e g omega, the Fourier transform of this particular will be 1. And here one more important thing, when we shift it by some n naught in time domain, then shifted unit impulse function, the Fourier transform will be 1 into whatever that was earlier, e raised to the power minus j omega n naught. Or if we want to, as we have seen for x e j omega for continuous time, in the shifting property, if we shift the sequence xt by t naught, then that Fourier transform will be x of j omega, e raised to the power minus j omega t naught. Similarly here, this term is getting multiplied with the Dtft of the del n. So this is one important technique. Now let us consider the calculation of Dtft for anti-causal sequence. One example we will take. Let us calculate the discrete Fourier transform of xn is a raised to the power minus n u minus n minus 1. So we need to calculate the Dtft for this particular signal. So how to calculate? Same formula we will apply, x e j omega, that will be summation n is equal to minus infinity to plus infinity xn, that is xn, a raised to the power minus n u minus n minus 1 e raised to the power minus j omega n, and mod of a is less than 1. Okay, solving this particular, since here now we need to see the limits of u m minus n minus 1. This is anti-causal sequence. So how it is anti-causal? Because it is defined only for the negative values and it is not existing for the positive values. So it is an anti-causal sequence, as we can see. So let us see the graph of this particular. So how we can make the graph of this u minus n minus 1? We are required, because we need to solve this summation and we want to see the limits of the summation. So for this, let us see u minus n minus 1. Okay, so u minus n minus 1, so let us these are positive values and these are negative values. So we can this particular is the folded sequence. So only the values are defined for the negative side. Okay, this is -1. Whenever there is a -1 for not non-folded, we shift it towards right. For this particular case, we will shift towards left. So the sequence would be from -1, -2, this is 1, -3, and so on. So my limit will be -infinity to -1. So my limit will be -infinity to -1. Okay. So in this way we can put the limit. So here we need to solve x e raised to the power j omega is equal to, now my limits will be from n is equal to -1 to -infinity. This is now 1, this is to be 1 now. Okay, so a raised to the power -n, e raised to the power -j omega n. So I can write it as okay. Now by the integration summation properties, this will be a e raised to the power j omega plus a e raised to the power j omega square plus a e raised to the power j omega cube plus and so on. And if I write the summation, then I can say this, put this a e raised to the power j omega as constant, and up to infinity this term is extending, and also we are given that this mod a is obviously less than 1. So we can write it as the summation property. For this, all these values we have written, so we can write it as 1 upon 1 minus a e raised to the power j omega. So the Dtft can be calculated in this way. This is x e raised to the power j omega, and we can calculate the Dtft for the anti-causal sequence, and we need to take care what are the summation values for the same, for the limits especially, so that we can calculate the Dtft correctly. Thank you.